Good afternoon, everyone. Welcome to AND 343, Best Practices for Building Apache Iceberg-based lakehouse architectures on AWS. I'm Purvaja Narayanaswamy, Senior Engineering Manager for AWS Glue Data Catalog and AWS Lake Formation. I'm joined by Mike Arojo from Medidata, Principal Data Architect, and Srikanth Sopirala, Principal Solutions Architect from AWS Data and AI Space. Today we have a packed agenda. We are going to start with the data lake crisis, what brought us here, the journey of Apache Iceberg in the lakehouse, talk about AWS's stack on how it's coming together as an integrated framework to work on Iceberg-powered lakehouses. And I'm going to focus on getting data in, the production-ready architecture patterns that you can build on Apache Iceberg. And Mike will cover the voice of the customer. You will hear Medidata's transformation journey on Iceberg. And Srikanth will focus on how open standards truly enable interoperability and focus on getting data out, the multi-compute integrations and optimizations in Iceberg-powered lakehouses. The key is you will walk away with some key takeaways that you can implement in production today. Data lake crisis. Data lakes were good on paper, right? Like you have flexible storage, disaggregated compute and storage, but in production it was a chaos. Right? Like data corruption was common. There was no way for you to go back to a point-in-time snapshot in case mishap happens. There was no way to roll back. Your queries were very slow. You're probably doing a terabyte scan to answer a megabyte question, and forget about schema evolution, right? Like you're now talking about rewriting petabytes of data, and it was such a hassle. And that's really where Apache Iceberg table format shown, right? Like you have this smart metadata layer. You have table-level snapshots with all detailed manifests, schema definitions, partition specifications, all separate from your data files. So this intelligent tiering and layout, right? Like with your table-level snapshots pointing to your manifest list, which tracks which manifest changed. And the manifest files themselves contain all the file-level statistics, your row count, min-max value, null count, etc. So this layout gives you a blazing fast query performance. And you get 5 core benefits right off the bat, right? Like first and foremost, you get ACID guarantees, right? Like multiple writers can simultaneously update the table, leveraging just optimistic concurrency control without hassle of any distributed locks and such. So you get that, and in production, like you don't have to worry about data corruption. Then the second benefit you get is because every update creates this nice table-level snapshots, these snapshots are isolated and immutable, so it acts as your checkpoint, so you can go back to a point-in-time snapshot and do a rollback and do time travel style queries, which is perfect for like your debuggability, for your checkpointing use cases and such. And the third benefit you get is schema evolution is very elegant. Iceberg tracks column by IDs, so whether you want to add, update, or rename a column, it's just a metadata update, unlike traditional systems where you have to rewrite an entire partition and such. The fourth benefit you get is query performance, right? Like you don't have to do expensive scans. Now, query engines are probably going to have to do, like, say, a few kilobytes of your manifest scanning and knows exactly which data files to read because of this metadata layout that I spoke about. And Iceberg also supports elegant row-level updates. So unlike, again, traditional file systems where you will have to, rewrite the entire partition, in Iceberg, you have ways to do it more effectively. So in Iceberg v2, there is support for equality deletes where you track the delete files by row key values, or positional deletes by row positions, and engines would appropriately apply these delete files along with your data files. Now with Iceberg v3, the gap is closed even further, right? Like the first and foremost variant type. JSON is everywhere, right? Like whether it's your API responses, IoT payloads, event types. The good thing now is engines natively support variant type. Otherwise, you would have to do some kind of an ugly flattening where most of your column values are probably null, or you have to transform it to a string and give up on query performance. Now, the good thing here is under the hood, you still get the optimized columnar benefit for your semi-structured data, and you still get that elegant query to render it as JSON. I spoke about the row-level updates where delete files are tracked as equality or positional deletes. That can get a little more expensive if you think of a table with million rows, and it's a CDC style delete heavy. You're now looking at an expensive operation in terms of merging those delete files with data files. That's where deletion vector is a game changer, because it just maintains a bit to track whether your row is deleted or not. So you're literally talking about loading this entire bitmap in memory and operating at memory speeds, and you apply these with the data files. And V3 also supports row lineage. Typically, lineage is tracked at a table or a partition level. Now with Iceberg V3, you get the provenance record for every row, right? Like it tracks your ingestion timestamp, source identifier, your CDC, database transaction identifier. So you have that complete auditability information. So in case a row is ingested, a bad data got ingested, you have the exact lineage to track where it came from. And the fourth benefit with V3 is support for default values. This is a huge operational pain alleviator, right? Like think of a scenario where you have your gold aggregator table, you want to add a column value, and now you're looking at either historical backfill of all your old records, or your query results are inconsistent where you probably throw up null for your old records and the new values for the new one. Here with V3, you have a way to specify a default value at the schema level, so engines can apply those for your old records, and your results are elegant and consistent. Great. So now we understand why Iceberg is taking the front seat in building this modern lakehouses, right? Let's look at AWS's stack briefly. So at the bottom layer, you have all these diverse data sources, whether your data warehouses, on-prem databases, streaming sources, external Iceberg compatible sources. So you're bringing in all that through our portfolio of ingestion services. It could be batching services like Glue or EMR, or it could be your streaming services like Kafka, Kinesis, Firehose. And you're bringing it all as an Iceberg table format to your storage tier. It could be your flexible general purpose S3 buckets, or it could be your S3 tables, which is fully managed Iceberg capability. And then, or it could be your warehouse storage, Redshift managed storage, and you still are bringing it all as a consistent table format Iceberg. The moment all these come into the storage tier, the catalog automatically discovers all of the technical assets that's coming in. Your Glue data catalog acts as your technical metastore, with LakeFormation providing consistent enterprise scale governance, and SageMaker catalog for all your business metricing and lineage and auditability. And in the processing layer, you have your choice of AWS 1P compute, or your choice of compute, which are Iceberg compatible. So all that support natively Iceberg table format. And at the application stack, you have Amazon Bedrock for GenAI and ML applications, or QuickSuite for your BI use cases, or SageMaker Unified Studio for your analytic use cases. So if you look at the stack overall, it's an integrated ecosystem with zero ETL, eliminating the complexities associated with data movement. Query Federation lets you tackle and join diverse data sources. And Catalog Federation opens it up where you can connect to all other external Iceberg compatible catalog and truly build an open ecosystem. So this is an ecosystem that's all built for your flexibility and is not fragmented. I want to zoom in a bit on Glue data catalog in terms of how it takes the central seat for the Iceberg-powered lakehouses. In terms of what it is, it's a Hive metastore. It's also an Iceberg REST catalog with all the V3 support, all the goodness that I earlier spoke about. And the catalog also supports multi-catalog federation to other external Iceberg-compatible catalogs. So now this catalog stack is providing the standard interface that other computes can hook up to, or it could be, again, choice of 1P or 3P computes through standard interface if it is an Iceberg REST catalog. And LakeFormation provides you this enterprise scale governance, whether you're talking about your fine-grained access control needs right from your catalog, database, table, column, row, cell-level security, or it could be rich policy-based access controls like role-based access controls or tag-based access controls and attribute-based access controls. LakeFormation also supports what we call as this architecture called data mesh. It's basically a way to democratize your data where you have your different lines of producers that wants to bring in the metadata, say, to a central catalog for consistent governance. And from that central catalog, you can then do a secure data sharing to different lines of businesses, other organizations, or org units. And it also supports what we call as credential vending. It ensures that only trusted compute upon authorization gets scoped down access to your underlying data sources. And in terms of an Iceberg style layout, right, like as I was explaining how data and metadata sits closer together, the catalog is truly a fast lookup layer, right? Like, so you want to enable millisecond lookups, make sure that computes get direct S3 access, so they can leverage the manifest caching, parallel manifest processing, and you get that full throughput. So that's all what data catalog enables. And we are also seeing a trend where there is an uptick on the agentic lakehouse. Because the Glue data catalog exposes all the APIs through programmatic APIs, now intelligent agents can come in, they can discover the tables, schema, data quality rules. They can even, say, detect the schema drift and notify the data owners. Or they could even self-heal pipelines or optimize your partitioning strategy to get a better query performance. So overall, I would say we are seeing a trend where catalog is not just a control plane for compute and humans, but also all these intelligent agents. Speaking of Iceberg, we have to zoom into the S3 table buckets. This is a stack where you get fully managed storage optimization for Iceberg. Iceberg is great, but it needs maintenance. Small files proliferate, especially on high voluminous CDC style workloads, or small files keep accumulating. And because every updates are now creating these table level snapshots, at a point in time, your snapshots are going to blow up your storage cost. So you want to keep them lean. And if there are unreferenced files that are not referenced from any live snapshots, that also keeps lingering in your system, affecting your query performance at some point. So that's where S3 table buckets comes into play and completely does this behind the scenes. So it removes this complete operational overhead for you, which otherwise you would have to run separate cron jobs on schedules and constantly monitor these and do these off the shelf. So the first benefit you get is compaction. So we support different styles of compaction. The first one is bin pack by default. Make sure all your small files are optimally packed to a target file size. We also support sort or Z-order style compaction, depending on your query styles, whether it's on a primary column or multi-dimensional clustering queries. And S3 table supports what we call as policy-based snapshot retention. So depending on your time travel needs on how many snapshots you want to keep in the system, you can define a policy, and S3 tables would take care behind the scenes on automatically pruning them. And likewise, unreferenced file cleanup, orphan files not accessible from any live snapshots are constantly referenced and cleaned up. So overall, S3 tables provides a lot of configuration and control plane APIs as well, monitoring APIs. You have nice CloudTrail audit logging. It publishes these metrics like snapshot sizes, your compaction size, snapshot count, referenced file count. So again, you can think of an agentic lakehouse where agents can start monitoring these metrics and proactively optimize your storage tier for your lakehouse. Great, so we saw how AWS stack is coming together for Iceberg-powered lakehouses with the focus on Glue data catalog and S3 table buckets. Before I go into the core ingestion architecture patterns, I want to touch briefly on the Medallion architecture. This is a way for your data organization, right? Like you have your bronze layer, which is your raw data, ingestion, append-only style. You typically leverage services like crawlers for schema discovery, or it could be streaming services like Kinesis or Kafka. So you're coming in, typically a storage choice for your raw data is flexible general purpose S3 bucket, Parquet with Iceberg format on top. The benefit that you get from Iceberg in the bronze layer is you get this nice schema evolution, as I earlier mentioned, without needing to do a full data rewrite. And with Iceberg v3, we support semi-structured data. You get variant support. And you get this nice time travel capability without having to break your data pipelines, and asset guarantees, right? Like multiple writers can come in, ingest all the raw data, update the same table without stepping on each other. A pro tip would be you want to keep the raw data typically indefinitely. So leverage S3 lifecycle policies, enable Glacier, move them to Glacier after 90 days and such. The silver is a layer where you cleanse the data. It's your enriched, validated data where you can apply all your classification rules. You can do your transformations and such. Typically, leverage services like EMR Spark, Glue ETL. And storage choice could be like your general purpose S3 buckets or S3 tables, depending on your scale and need. The pro benefit that you get because of Iceberg in the silver stack is schema enforcement. Schema acts as a contract. And you get this nice partition evolution. So say you started off with a partition strategy and decides, depending on the scale and usage, you want to move to, say, you started with a daily basis, you want to now move to an hourly basis. The neat thing with Iceberg is the manifest are tracking partition by spec IDs. So all your new data that you're ingesting will start enforcing the new specification, while your old data can still continue enforcing the old spec. And Iceberg also supports this nice incremental updates. So you want to apply all these enrichment rules and transformation on the incremental changes that is coming in. So leverage Iceberg merge operations to be able to update those increment changes that's coming in. And you get that through also snapshot checkpointing, right? Like every update, you have this nice isolation of what was your last checkpoint, so you know what is that exact delta that you're working with. And gold is your analytics-ready, optimized consumption table. And typically, you leverage services like SageMaker, Athena, Redshift, like for your query analytic use cases. And the storage choice, definitely S3 table buckets for the gold layer. And the benefit of Iceberg in the gold is you get materialized aggregations that are typically stored as Iceberg tables. And you can leverage hidden partitioning on Iceberg. That means, like, when you're running the query, you don't actually need to know the partitioning strategy and technique. Based off of the column values, Iceberg internally knows like how to get to the exact data files. It will apply the right partitioning strategy. And definitely to reap the benefits of query performance, leverage sort or Z order, depending on your query patterns, so you get that query boost. And a pro tip would be, again, like you want to make sure like you leverage snapshot retention policy, so you are constantly optimizing the metadata layout for your better query performance. And a point to note is S3 tables offers like 3x better query performance and 10x higher throughput just by the sheer reduction of all this metadata overhead and optimizing the file layout. All right, now let's look at core ingestion patterns. First and foremost, batch ETL. This is like your workhorse style workload where you're moving voluminous amount of data on schedules. Typical use cases are like lake migrations, warehouse loads, historical backfills, or regulatory reporting. So you have your source data sources like RDS or on-prem DBs, and you're leveraging, say, serverless Spark for ETLing it, and write it as Iceberg tables on S3 tables, and catalog it on the Glue data catalog, and it's ready for your analytics consumption. So in this pipeline, the pro role for Iceberg is that you get this nice schema evolution. Adding, renaming, or dropping columns is very elegant without needing rewrites. You get this nice partition evolution without incurring huge scans and rewrites. And it provides you this nice time travel capabilities, and you get asset guarantees. So that way, anytime a mishap happens, you don't have to like disrupt the rest of your ETL pipelines. You can go to a consistent point-in-time snapshot. And you get this nice row-level lineage with Iceberg v3, so it provides you this better auditability and debuggability. Pro tip, definitely leverage S3 table buckets for your optimized, faster queries. And you want to tune in the file size if you're leveraging, say, bin pack algorithm to understand, hey, what is my pattern? How do I optimize my query performance and such? Understand your data, if it's time series partitioning strategy based off of date and time, or if it's region-based or geo-style data, you want to partition it differently, and enable sort or Z order for better query performance. The second popular pattern is change data capture. This is your style ingestion. This is real-time replication from operational databases to analytics. So you have all the source databases, Aurora, MySQL, RDS, leveraging the change data capture from bin logs or your write-ahead logs. And you leverage typically database migration service, and all these captures are coming in and go through Kinesis or Kafka for stream buffering and replay. And then you're leveraging Flink or Spark for doing the transformations, and you merge them into Iceberg format on S3 tables, and then it is ready for your analytics consumption. The pro role for Iceberg here is you get this efficient upserts, the merge operations, because you get all these small captures, the delta changes that is coming in, and without doing full rewrite of the entire partition, you want to be able to know exactly which rows to update, and Iceberg does that very efficiently. You know the exact rows to update, so it rewrites only those files because of this nice optimized layouts and updates the manifest atomically. It supports two strategies, copy on write and merge on read. Typically for a CDC style workloads, we have seen customers adopt merge on read because it's more write heavy. And definitely leverage deletion vectors, much more optimized for performance, so you can bring the entire bitmap in memory and operate at memory speeds when you want to apply those deletes. And you get this nice snapshot isolation, so even when CDC streams are coming in and ingesting, you get a consistent query performance, and you also get consistent reads on your analytics side. And definitely leverage auto-compaction, and concurrent writers can update the same table without stepping on each other. Pro tip would be definitely bring in the files in Parquet format. That's generally better for your compression techniques. And you want to monitor the lag through your entire pipeline, whether it's your DMS or Kinesis, like where your latency is going up. So you can optimize your CDC pipeline, and definitely leveraging deletion vector if your workload is write heavy with more deletes. The third popular pattern is high concurrency streaming ingestion. As it stands, right, like you have this clickstream analytics, financial transaction, gaming telemetry. So we are talking about like all these IoT apps coming in through, say, Kinesis streams, high throughput, multiple streams, and say Flink is doing some real-time aggregates, and Spark is doing some complex transformations, and they're all writing to the same table. You write it on S3 tables, and then ready for consumption. So Iceberg is perfect for this because you have multi-writers, you get that consistency, leveraging optimistic concurrency, you get this nice read consistency on the consumption side, and small file handling is perfect with S3 tables. And you get this nice exactly once semantics because snapshots provide this nice checkpointing, and combine that with your Kafka offsets, you get this nice exactly once semantics. And Iceberg is perfect for all these incremental processing. So you read only and do the transformations on the delta from the last checkpoint. Pro tip, definitely perfect choice for these workloads is S3 tables. So you get all the automatic storage optimizations. And especially in these multi-writer scenarios, you want to monitor for the commit conflicts. So you want to tune the concurrency accordingly. And typically, we recommend customers to do some namespace isolation so they don't step into the same partition. You have this nice segregation of high-frequency writers. And you want to, again, understand your pattern and tune in the microbatch size to balance the latency versus file count. And you get all the goodness right off the bat, leveraging AWS components. Great. So overall, we saw batch ETL, CDC, and high streaming concurrency, where with Iceberg benefits and S3 tables and Glue Data Catalog and analytics services, you get all the core benefits. Over to you, Mike. Let's hear the transformation journey of Medidata.
OK. Thank you, Purvaja, for that amazing introduction to some of the popular Iceberg architectures we're seeing emerge today, as well as the amazing AWS services that are helping make those a reality. I'm Mike Arujo, an engineer here at Medidata. And before we start looking at our customer journey and our use cases, here's a little note about who we are and what we do. And so Medidata is a life sciences tech company that has been working on innovating and providing digital solutions to our life sciences, pharmaceutical, and healthcare companies across our 25+ years of experience. So our principal use case today, we're going to be looking at two of our newer offerings in Data Connect and Clinical Data Studio. And the purpose of these new offerings was to bring the data under a single roof for our customers to interact with. So we wanted to bring a single source of integration regardless of where that data came from. We wanted to support that and enrich that data with semantics via our internal data catalog, as well as accelerate the data review and insights process through AI and machine learning. And so, as you can imagine, over our 25 plus years, we've seen millions of patients enter under our roof, which has resulted in the consolidation of billions of data points that have emerged from these various data sources. And so one of the things we were really hoping to do is reduce the friction that customers experience today, generating ad hoc analytics data sets and data assets for that aforementioned insights through AI and machine learning. And so this is a look at the previous architecture that we used to do to accomplish this type of thing. And so this probably looks very familiar to a lot of people in the audience, and this pattern works very well and has been working very well for a long time until the recent data explosion that we've kind of been seeing emerge today. And so we have our bronze layer consumers and collectors on the left side, including our flagship Rave platform, which is our raw data collection system, and our legacy ingester solution, which was used for file-based integrations. And so what you kind of notice here is a lot of those ETL blocks. So there was just all these different batch jobs going on that had to land in some different staging layers and for processing before finally making it to some downstream resting point where your consumers would then pick it up and read from it. But the reality is you probably didn't have just one of these pipelines hanging around. You probably had many of them because your consumers probably had various different requirements for how they wanted to read that data. You might have had streaming consumers, application consumers, APIs, BI solutions. The range is very wide, and so you probably were replicating pipelines like this all over your organization to try to satisfy all those. And so obviously, you probably ran into all the same issues that we started to run into with solutions like this. As the data began to scale, we started to see the latency deteriorate and started to become measured in days instead of hours or minutes. The inconsistency with the timing for each of the individual jobs meant that it would be kind of difficult to align all of the data as it moved through the system, especially since we had collectors collecting data at all points at all time. And so with that many batch jobs running and that many places to store the data, you increase your opportunity for error. Places where things can go wrong, inconsistent data throughout the pipeline solution as the batch jobs kind of fall out of consistency. And if you needed to scale this, you needed to accommodate billions and billions of data points, you were probably looking at an overhaul of your entire system, possibly a data migration. And the net result is numerous copies of data all over the place for different use cases at all times, right? And to make matters worse, if we wanted to throw observability on this, we were talking about replicating that observability across the entire data estate. And so this is a look at how we solve this challenge today with Iceberg and AWS. And so we still have our Rave solution collecting data on the left side. We've replaced the ingester solution with our new solution, Data Connect, right? And so what's happening here is we got rid of all those ETL jobs that were running on some cadence in the middle, and we got rid of all of the intermediary storage layers and staging layers that we had needed before. Because what's happening here is Iceberg, as you can see from the far right, kind of plugs right into anything you want from a consuming perspective, right? So that meant that what we could do was if we could fill up this Iceberg sink in the Glue catalog, we were going to get immediate interoperability with a number of different streaming solutions, batch solutions, warehousing solutions, other open source projects like Arrow, right? And even MCP tools that we can then feed into our AI solutions. And so, right before that is the streaming piece that I was alluding to before. And I just want to highlight that for a quick second, because as some of you guys are probably aware, Iceberg, if you write a lot of snapshots from a lot of writers, you start running into all sorts of problems with file sizes, small files, lots of snapshots, right? And so by Putting Flink inside EKS and using a Kafka buffer in the middle, we could just write to that Iceberg table once every 20 minutes and keep our snapshot size down while aggregating data from thousands of Flink pipelines. And so let's take a look at what that architecture delivered for us in terms of results for us and our customers. First, the data availability. Naturally, or perhaps unsurprisingly, when you move from a batch pipeline to a streaming pipeline, you see a significant reduction in latency. And that's exactly what we saw. And so that reduction in latency consequently meant that our customers were seeing consistent views of the data. The glue compaction was ensuring that the data could be retrieved timely. It was abstracting away all of those frustrating complications with the small file problems, the orphan file deletions, and all of that stuff. And so that's one of the things that we worked very closely with the Amazon team, who was incredibly receptive and helped iterate over that to deliver the solution you see today. And then finally, the snapshots were giving our customers and ourselves point-in-time access to the data. The integrity was significantly improved. So now, instead of having data all over the system in Kafka topics, in staging tables, in Snowflake tables, in Databricks tables, in whatever tables, we had a single copy of the data. One copy, one Iceberg table. And that table was able to satisfy both the streaming and batch use cases, so we were able to unify that estate there, as well as serve application interfaces, APIs, BI tools. And so as a result, we had a significant reduction, unsurprisingly, in data loss. We just had to focus on this one copy of this data, and we knew that everything reading from it was reading from the same thing. The scalability. So now that we were working with data stored on S3, we no longer had to store data throughout its lifetime inside Kafka. That allowed us to let Kafka do what it does best, which was consolidate across all the writers and transport data downstream. And so this actually saved us a whole lot of money, unsurprisingly, because all of the lifetime data was sitting on S3, which we could storage tier and all that, instead of in Kafka, where you'd have to kind of scale up those servers and all that stuff to store all of that. And so, of course, the Kafka and Flink solutions that are running on EKS and MSK come with auto-scaling support out of the box. And so, unsurprisingly, our observability was significantly enhanced and simplified. We were getting all of the amazing metadata coming out of these pipelines and the metrics, the Prometheus metrics and all that stuff. And we just had to worry about looking at that within a single plane. The security. So now we have a single data access layer with the Glue catalog, so nothing can get in the door to see our data that doesn't go through Glue and the corresponding IAM roles. Additionally, the data now never leaves our VPC, so the data is just inside S3 in our account, and whatever we decide to plug in as a reader can plug in as a reader, but we're not storing physically any copies anywhere else. And then the integration. So like as I alluded to on the diagram side, the integrations that were available to us significantly expanded. Warehousing solutions like Snowflake and Databricks plug right in. Iceberg REST API delivered via the Glue catalog has made it possible for a number of advanced Iceberg concepts to be put in place. And then finally, a bunch of open source technologies. We're talking streaming writers, readers, SQL solutions are out of the box, enabled, and more coming every single day. And so this is just kind of a snapshot of all those benefits that we've been talking about. So the availability, the integrity, the scalability, the security, and finally the integrations. And so what's next for metadata with Iceberg? We're looking to equip our coming suite of AI agents with the real-time data that's flowing through these Iceberg tables. So we want to give our agents insight into data, watch our customers upload new pieces of data, and then start asking questions about that data minutes later. And our current plan, something we've been working on, is to basically make that available through MCP tools that have access to this lake. We want to enable and expand upon our customer data sharing solution. So we've recently launched a solution that gives customers direct access to read the data that lives in these Iceberg tables, but we want to expand that to allow customers to do writebacks, direct writebacks into the lakehouse solution as well. We have our metadata curated SDKs, including our recently released RStudio SDK, which actually allows customers to write our code on their local laptops, reading data that lives inside this lake. And that's all made possible by the open source Apache Arrow project, where we've stood up a flight server that gives the connection and the bridge between our studio and our lakehouse. And then finally, direct integrations. We want to be able to open the box so that if customers are using Iceberg today as part of their solution, we can kind of plug right into that and integrate that with the rest of the experiences that they get to enjoy in Data Connect and Clinical Data Studio. And so finally, some excitement on our side for what's coming in V3. There's the variance support, and so metadata, we saw the Iceberg table that was writing from those thousands of jobs. Well, that was because those thousands of jobs are actually writing multiple tables. It's a multi-table table within a single table. And so we've been taking extensive use of the map column. And the map column worked great for that use case, but it does lack in some areas, including indexing and query performance for some tables within that table at scale. And so we're looking forward to replacing those map columns with variants, where you can actually get that way better performance against a subset of a table inside another table. The default values, we want to enable the column defaults so that we can save ourselves days and days of backfilling. And so right now, if we have to make a schema change or we have to evolve or move some sort of process there, it actually takes days and days of backfilling to get the table back up to current. And so the column defaults promise to save us all of that. We don't have to worry about any of that migratory patterns, anything like that. That can get a little tricky and a little complicated. This is going to be a great feature for that. And then finally, the row-level lineage. Our customers are constantly obsessed with seeing how the data changes and evolves over time. And so while we've put in features to help give them a clear picture of that, a lot of it is not out-of-the-box solutions and tooling. It's navigating snapshots. It's looking at timestamps. It's doing date range comparison and all that stuff. But in V3, Iceberg is coming out with row-level lineage. And so what we want to be able to do is plug this row-level lineage right into our CDC pipelines and then expose that to our customers directly so that they can see the change of the data and we don't have to spend hours and hours writing custom code and custom SQL to surface that to them. And so now I'm going to hand it off to Srikanth, who's going to show you some of the amazing things that Amazon's doing to help make this possible for their customers today.
Thank you, Mike. So I think it's great to see customers like Medidata use Iceberg and provide the solutions to their customers. But I think what I want to do is I want to kind of touch on the consumption patterns in terms of Iceberg with the AWS compute engines. So first of all, before I do that, I just want to double click on the open spec. Why is it important, right? I mean, if you think about it, fundamentally, open spec changes that game, that how you consume your data with standardized table semantics and also interoperability. I think that's very important for us, right? And also, and then catalog choices. Purvaja talked about catalog choices because the Iceberg's openness in terms of catalog choices with AWS Glue, Hive Metastore, or any other catalogs that you can bring in custom catalogs, the automatic schema evolution, the ACID transactions, and also the accessible metadata, all of these features are really important with this open spec. Now, the other thing also to think about is the multi-cloud and multi-source integration. Right? Because we talked about, imagine you're doing this operational logs in S3. You have a bunch of operational logs in S3. You have SaaS app exports, and you're trying to bring all of that data, third-party marketing data, into one place, into Iceberg tables. I think which can be governed, centrally in one place. I think that the open spec basically provides you that. And finally, open discovery features. Right? These are important features because the enterprise-wide visibility, because it's compliant. For if you're sensitive data sets, comprehensive lineage and standard definitions can also be offered with this open spec. So the reason I wanted to kind of touch on the open spec, which is important for us to kind of continue with this discussion. Okay, with that, let's get into the query federation. this is an important topic, right? We have seen how open table spec, unlock interoperability. We've seen that. Like what we can do is, what is query federation, right? Why is it transformative? So if you think about it, given the centralized governance and the metadata management, by plugging every source, right? For example, you have a unified catalog, you have everything that is findable, and also you can audit and secure all of this data right out of the gate. I think that is important for you, right? So the idea of the open, the query federation is, this is the data residency and compliance. Also, it provides you the front and center, which is basically stands out there. For example, since the federation of the queries, the data is in place. You're federating the data in place across the multiple data sources. So this provides a really important use case in terms of when you come to Iceberg. And also the other thing is, the agile analytics becomes really, really important in this case, right? Think of this. If you're trying to have analysts who are trying to get to the data with multiple sources without moving any data, without any data movement, query federation becomes a very important aspect in their analysis. And then lastly, the cross-source reporting, right? Because if you think about it, the cross-source reporting, where you have all of these data sets across, it could be multi-cloud, it could be multi-vendors, you are bringing into one Iceberg format with an API where you can access all of that data. So that provides you that thing. But so for that, what we've just announced recently, if you've seen this, the catalog federation of external Apache Iceberg catalogs. So what does it do? So with catalog federation with Iceberg, right, your teams can kind of query the Iceberg tables sitting in S3 directly, which is very important, right? And also using whatever analytics compute engine that you want, you can access that data. And also it keeps the metadata synced between catalogs, not just the AWS Glue catalog, and also the other catalogs, outside catalogs, right? It could remote catalog. So when you hit a table, you're basically looking at the data that's coming from the other catalogs, they're all in sync, which is important. This is an important feature for that. And then lastly, it gives you consistent centralized security across all of these things, right? With the option to, of course, this is optional, where you can apply the broad policies in any of the fine-grained or column level access through lake formation. Depending on the use case, you can use that there. So the federated catalog basically becomes an important part because it's integrating multiple catalogs into Iceberg formats. Now, materialized views are fundamentally important when it comes to performance, right? Because if you think about it, the materialized views provide the supercharge your analytics, because it provides the pre-computation in there. Like for example, the way to think about this is basically a few factors here. One is implementation strategy. Think about, what you want to identify is, in terms of best practice, you want to identify what are the high frequency or what are the queries that you are using or your users are using constantly, and then set up a refresh schedule where you can have the views basically accurately and timely refresh that. So that's the implementation strategy. And then of course performance design becomes another important factor here, right? So what does performance design in this case mean? Like pre-aggregate metrics and also optimize those joins to deliver the right lightweight, fast analytics for your customers. And then storage optimization. Storage optimization becomes very, very important, because I know Pooja talked about storage optimization. So storage optimization is by formatting your tables in Parquet, stretching the right compression, and choosing the right compression, participating, the partitioning very smartly, and also every query kind of scales up without blowing out your complete storage costs. So that's an important aspect of it. And then the refresh management. Refresh management becomes an important point here too, is because it keeps the insights refreshed. So you want to kind of figure out your refresh schedule. How do you want to refresh, what are the schedule looks like? So that's an important aspect of that. And then finally, metrics, right? ROI. You have to be able to measure this performance. So you want to kind of looking at the major cost reduction. You want to look at rapid query optimization, and also you're from milliseconds to from seconds to milliseconds. You want to kind of measure that, measurable improvements. So those are important things there. So the idea of the materialized view is it gives you this pre-computed aggregated way of accessing your Iceberg data. So that way you can get better performance. On this note, we just announced the materialized views in AWS Glue. So think of materialized views in the Apache Iceberg. What are they, right? These are materialized views. Think of this as a managed table that stores the output of a SQL query in Iceberg format, and that's what these materialized views do. And then rather than constantly rerunning that query from scratch, what the resource, the tables change, the view is incrementally refreshed constantly. So you don't have to do anything. So it kind of eliminates that whole pipeline building where you have to constantly refresh that. So that's what Glue materialized views for the Apache Iceberg do. And what are the benefits, right? You might be thinking, okay, how does it help me? So the performance benefits are huge with this materialized views with Apache Iceberg, right? Because the results are pre-computed, and then they're also stored in Iceberg tables. They're super fast, right? The Spark jobs that are reading from these views, what they can do is they can figure out whether the materialized views is the right approach for them, or they're going back to the tables itself. So you have that intelligence built into with those things. And then it becomes, if you're building pipelines and if you're building complex pipelines, these materialized views can help you build these pipelines, simplify these pipelines with help of those things. So this is a cool feature and one of my favorites here. So here's the thing. I know Pooja talked about it, but I just wanted to kind of flash this screen out just to give you guys an idea, right? Apache Iceberg is becoming the go-to table format across the board, across the analytics, and every customer we talk to, I think they're embracing this approach, right? And then also, what we have done is we have built multiple data integrations across the entire ecosystem. So if you think about it, on the producer side, we have all of these tools. Like we have, your data lake foundation, your EMR. We talked about, Athena. You have that integration across our analytics stack, so you can produce the data into Apache Iceberg tables. So that's huge. Plus, now I talked about catalog federation. Now you can kind of get that catalog federation from remote catalog, so you have that center there. And then you have, with the open spec, and we talked about API, you can have Spark or Trino or Presto. You can consume all of the data across these different tooling. So this becomes an integral part as you're thinking your architectures. Think of this. These are components you'd be thinking about. Now. Now that we have talked about the services that can consume data, let's double-click on few of the services like Amazon Athena, and then we'll talk about a couple of other services here. How do you optimize, Iceberg data consumption using Amazon Athena, right? One of the biggest, wins here is the Athena ability, to leverage Iceberg's manifest files and partition stats for aggressive metadata pruning is very important, right? I think with the right partition, with the right filter predicates, Athena kind of skips that whole irrelevant Parquet files, and it helps you with that performance. So that's important. And also data management. Data management kind of goes beyond just querying, using CTAS like create table as, right? You can build new Iceberg tables. You can write inside Athena, which I think which is important with SQL, enabling the snapshot isolation that Pooja talked about, and also branch and tag support in Athena using these Iceberg tables. And then the last one is the serverless scaling, right? So serverless scaling is pure simplicity, because if you think about it, there is no cluster management. You don't have to worry about managing any cluster to access your data in Iceberg tables. So Athena provides you that serverless management and $5 terabyte, which is pretty cost effective in that. So in terms of best practices with Athena, think of partition predicates and filter conditions while you're designing your Athena queries for every query, right? Leverage the manifest statistics and CTAS for fast and efficient writes. And also, this way Athena and Iceberg kind of work together, and then that provides you the best performance that you can get. Of course, the bottom line is Athena plus Iceberg, it's a true pay-as-you-go analytic solution for you, right? Because there is no cluster management, it's cost-effective, and then you can access that Iceberg tables with all the features that I talked about. So let's talk about Redshift. So Redshift is a very popular data warehouse out there. A lot of my customers use it. When you're ready to take your lakehouse analytics to next level, it's the enterprise scale. People generally look at Redshift. So Amazon Redshift and Iceberg kind of really work very together in terms of performance and scale. On the consumption side, if you think about it, Redshift excels the concurrency and also the efficiency. Right, you can easily handle 50 plus concurrent queries at the same time, and also systems auto-scaling and workload management really help with these Iceberg tables. And then for the modern lakehouse integration, Redshift has built-in support for the Apache Iceberg tables. It's a powerful combination where what you're able to do is you can get direct read-write to Amazon S3 with snapshot isolation, with also full compatibility with both BI and ELT workloads. And then everything too is tuned because once and the cost control, because Redshift uses statistics that are based on planning and also optimization so that your queries can perform better well, because they provide you that query rewrite, so you're able to do that quickly. And then in terms of best practices that are revolving around RA3 nodes, right? Because for optimal storage and compute, separation, I think leveraging concurrency scaling, which is important aspect of Redshift, and also cross-cluster sharing, which is also a key thing for the enterprise needs. And then performance monitoring, and then performance metric using various other tools, you can do that. So the other thing also is the query latency and concurrency, because the cache hits for smooth, predictable operations. Redshift provides you those things in there. So some of the best practices for Redshift. The other compute engine we see a lot is EMR. Right, because EMR Spark makes, or Spark in general makes scalable Iceberg analytics really both cost efficient and also enterprise ready in terms of the lakehouse architecture. So for in terms of infrastructure, you think about the flexibility. Right, clusters can be ranging with EMR from any single digit nodes to handling 1 to 100 terabytes of data at the same time. Right, you can do multiple clusters, and using Graviton provides you that ability to just spin up those clusters. Of course, the performance kind of hinges on the runtime optimization, right? Because specifically with Iceberg, Spark gets adaptive query execution, and also smart join planning and dynamic partitioning are all available as part of that Spark. So even with your largest data jobs, you're able to now use millions of partitions of petabytes, so you can consume that data and you can run that effectively. And then the storage integration is key, because storage integration ties all of these together. You get the S3 committers, which are the full ACID transaction support, and also schema evolution, that making it very easy to manage and reliable versioned data sets. Of course, the EMR Spark plus Iceberg, I think they're built for all of these analytics, right, which we talked about. ETL pipelines, streaming ML workloads, and also ad hoc queries. No matter what the workload type is, few of the core best practices to unlock this scale is right-size your partitions. That's number one, right? Between 128 meg to 1 gig, which is not new, that's a standard practice. And also tune your executor memory for maximum performance, and then enable the adaptive query features, that shuffle optimization. So the bottom line is, EMR Spark, Iceberg lets you build the fast, flexible, and also cost-optimized lakehouse analytics, with massive data, machine learning, or even ad hoc analysis, and also even streaming to run smoothly with this kind of feature. So that's EMR Spark. Let's get to key takeaways, right? In closing, so the key thing to remember is, some of the key takeaways that really set Apache Iceberg for modern lakehouse architectures on AWS is the foundation, right? Think of the foundation with enterprise data features. Think of ACID transactions. Think of time travel that Purvaja talked about. Think of schema evolution. Think about all of those. All of these things come standard, right? That's important. And then the other thing is, if you're building for the future from day one, when you're architecting a solution with Apache Iceberg, you're basically building for that. And also by leveraging S3 table buckets, which we talked about, every query gets this speed boost in terms of high performance, high throughput access, and then so use that. And then with AWS taking care of the maintenance and managing that Apache Iceberg tables. And for high performance analytics, I think you've got the built-in engine-specific optimizations, whether you're planning Athena, whether you're planning Redshift, or whether you're planning EMR or Spark. Iceberg's Materialized views that we talked about, query federation, which is a fundamental thing that you want to kind of start thinking about, and also catalog federation in that respect. These are for fast cross-source analytics, provides you a better insights that you can quickly access. Of course, in production, the key thing to remember is Iceberg isn't just about batch jobs, right? Because it powers real-time things that, like we talked about, one of the use cases that Purvaja talked about, change data capture, and also streamlining the workloads. So the idea here is to get you the sub-second latency across the wide concurrent writer support, and also make your platform more responsive, and that's an important thing. So in terms of best practices, when you think about it, start new projects with S3 table buckets if you can, because that's then optimized, managed Apache Iceberg server layer that is available for you. And also file sizes. Think about the file sizes that I talked about. For storage efficiency, use smart partitioning for agile queries while enabling catalog optimization, and also for quick searching and configurable snapshot retention in terms of balancing your reliability and cost. So here's the action plan for you guys, right? Use S3 buckets and right-size files for all your Iceberg projects if you can. Set up snapshots and partitioning to future-proof your performance, number 2. And then also lean into materialized views. I talked about glue materialized views, lean into the materialized views because the pre-aggregated, pre-computed things, I think they provide you a valuable, they reduce your data pipeline so that way you can quickly get those, particularly glue Iceberg views that we talked about. And also make catalog management a priority. Think about catalog federation, whether using other vendors, whether using other catalogs. Try to use catalog federation so you can consume your data, so you get the best compute irrespective of which platform are you in. So in terms of the Apache Iceberg, the way you deliver speed, the way you deliver scale, the way you deliver flexible analytics is using Iceberg with these compute engines, right? So making your workflows more productive, and also as a life as your data engineers or data architects or whoever, it makes it easy for you to kind of consume that data. So that's my last slide. Thank you. Thank you for coming to this session, and enjoy the replay party. Thanks a lot.